Hi everyone, welcome back to the channel. I'm Hussein Younes, and today we're going to be continuing our series on AI agents. In the first video, we have defined the AI agent term, and we have built an AI agent with tool calling, and I've defined the concept of calling tools. In today's video, we're going to be focused on the memory and state management, which is a very important concept when building AI agents. So what is the problem that we're trying to solve with memory? So by default, large language models, which are the main building block or the main engine of AI agents, they do not have memory by default. So let's take an example, ChatGPT. ChatGPT is built on top of large language models like GPT-4 and GPT-5, for example. And those large language models by default, they do not have memory. They do not possess the ability to recall previous conversations by default. That's why ChatGPT actually adds the concept of memory to give the LLM the ability to remember the conversations that it had with the current user, and also to remember the previous messages that are going in the current conversation. So think of the LLM or the agent without a memory as a person with amnesia. Whatever you tell it, it's gonna forget very quickly. Therefore, it creates a very poor user experience. So we solve that with memory. Memory is basically a way to preserve the state of the agent between the turns of the conversations and between the queries of the user. What we can store in the memory, for example, we can store previous messages. So the previous messages that have been sent in the current conversation. We can store in it the context and preferences. So we can store the information of the user profile, their preferences. So the agent can basically process queries based on this context. We can also save some calculations that the agent have done before and the tools that has been called so far in the current conversation. And the conversation flow itself. So the conversation flow will be enhanced whenever we give the agent the access to the memory. In LangGraph, because in this series we're building AI agents with LangGraph, which is a Python library built by LangChain. In LangGraph, there are three main concepts or three main components to a memory. First, it is checkpointer. So checkpointer, you can think of it as the save game button in a game. So whenever you're playing a game, you want to save the game in a state, or like you want to save a checkpoint in the game so you can come back later to it and continue that game from where you left off. Then we have the thread ID. So the thread ID is basically the conversation identifier that we're using to separate conversations from each other and to know which conversation we want to continue next. And then we have the message history, which is a very core component of the memory. So in the message history, we save all the messages that have been exchanged between the user and the agent throughout the conversation. So these are the three main concepts or components of a memory in LangGraph. So let's dive a little bit deeper on the checkpointer or on the memory. So in LangGraph, we can import the memory from the checkpoint module, and we can create a memory saver. So a memory saver is basically the class that is going to be used in order to save the state and the memory to the agent. So in LangGraph, the agent can be thought of as a graph, as we've explained in the previous video. So whenever we create the graph, whenever we compile the graph, we can give it the checkpointer or the memory saver that enables the agent to remember this state and to preserve the state between the turns of the conversation. And also we can even save it for later use whenever the user comes back to the same conversation. So the context will not be lost. So there are three main types, or even more, but like these are three types of checkpointers in LangGraph. One is memory saver. So memory saver saves the conversation in the RAM, in the memory. So whenever you shut down the agent or you shut down like the server, for example, the memory will be lost because it was saved in the RAM. And there are database-based memory or checkpointers in LangGraph, like SQL and Postgres Saver. With these ones, you can persist the state between server restarts, for example. And there is also Postgres Saver implementation, which can be used for scalable, reliable production applications. So without the memory, you would just call or invoke the agent and give it the list of messages. And then the second time you invoke and call an agent, you also give it the same set of messages. So each invocation is independent. The agent has no awareness of previous interactions, and the context is lost between the agent invokes. While when you give it a checkpointer, whenever you have, so when it has a checkpointer, when you compile the agent with a checkpointer like this, when you give it a memory saver. Now, whenever you invoke an agent, you need to give it a configuration that contains the thread ID, which is the conversation ID that you would like to continue now. So in this case, for example, it's chat1. So whenever you call the agent, whenever you invoke the agent, you're going to give it the configuration. So you're going to tell the agent, now I'm going to continue the chat one. I'm going to continue this conversation. So the agent will recall all the context, all the information, all the message history related to that conversation, and it's going to enable the user to continue that conversation without forgetting the memory or forgetting the context. So the second time you invoke the agent, the state and the context will be preserved between these runs because now the agent is memory enabled. So this is the difference between an agent with memory and an agent without memory. So now let's check the coding example. Like we've done last time, we will define a tool. So we will build an agent with tools again. So you can check out the previous video for a more detailed explanation about like what a tool even means and how we can call tools using LangGraph. So if you haven't watched that video, just briefly, a tool is basically an external source of actions that the agent can make. For example, it can go do some calculations, or it can like go search the web, for example. So these are tools, external tools that we give to the large language model. So in this case, we're gonna create two tools. One is addition tool. So it's just a tool that adds two numbers. So whenever we tell the agent to make any addition operation, the agent should actually use, if it's correctly configured, it should actually use the addition tool. Then we define a multiplication tool, which just the same thing, but multiplies two numbers. Just for your information, I'm gonna be uploading the code, so you can check it out later in more details, and let me know if you have any questions in the comments section. Then we need to define the state. So this state is the thing that we're gonna preserve throughout the conversation. So in this case, it's a list of messages. It's very similar to the state that we have defined in the previous video, but in this case, we're gonna persist this list of messages and the message history between conversations. So the state in this case is just, as I said, just a list of messages that has been exchanged so far with the agent. So you can think of it, for example, in the ChatGPT example, as just the message history that has been interchanged in the current conversation. So after that, we're gonna create the agent with memory. How we're gonna do that? First, we need to define the brain of the agent, which is the LLM. And the LLM in this case is Claude Sonnet 4.5. And we're gonna give the agent access to the tools. How we do that? We do that with the bind tools function from LangGraph. And we can give it the list of tools that it has access to. In this case, it is addition and multiplication that we have defined earlier. And then we define the agent node. So the agent node is going to take these tools and is going to invoke the agent. It's going to call the agent basically whenever necessary. Depending on how we define the graph, and I'm going to show you how it looks like, how the visualization of the graph a little bit later. So when we call, whenever we call the agent with tools, we give it the state, the messages, or the state that we have so far. So we give it the current conversation, the current messages that has been exchanged between the agent and the user. So it can basically go take this information and answer the current user query. And we're going to see that in action in a moment. After that, we define the router. So the router is basically, it's called should continue function, which is the router function. I've also explained the router function in the previous video, but just in short, a router function is a function that tells the agent what to do next. So it can, for example, in this case, if we have used a tool, if the LLM decides to use the multiplication tool, it's gonna route the execution towards that function, towards that tool. Otherwise, it can just return to the user. So it's return the end string, which tells the agent to route the execution to the end of the graph and return the answer to the user. So then now we're gonna define the graph itself. So the graph is a static graph, and we give it the state, which is just the list of messages. After that, we define the nodes, we add the nodes. So we have the agent node and we have the tools node. So this is how it looks like actually. So we have the agent node. So this is the main node that has access to tools, right? It has access to these tools. And we have the tools node. So the tools node is where the tools are going to be executed actually, because the agent node is just an LLM node that will make decisions to use tools, but the tool node will actually go and execute those tools functions. And then we have the end node and the start node. The start node is the entry point to the graph. The end node is the final node in the graph. And then we have a conditional edge. So the conditional edge is these dashed lines, right, that we see here. So it's a conditional because it's either can go, an agent can either make a decision to go to use a tool, or it can make a decision to end the conversation and go back to the user. So that's actually pretty much the graph definition. Now the important part, which is the memory part. So for this case, we're going to use the memory saver, right, which is in RAM, in memory. It saves all the context, all the state in the memory. And we define it in a checkpointer, and we give this checkpointer to the graph compilation. So whenever we compile a graph, now we give it the checkpointer, which is the memory saver. And the memory saver is going to handle all the context saving between the conversation terms and between the conversations in general with the user. Now let's run it. Let me run the code and explain to you what's happening. So now we're going to run the code. We're going to define the agent with memory, right? And then we're going to give it the conversation 1. So in the first conversation, we tell it, the user says, "Hi, my name is Alice." And then the agent replies, "Hello, Alice. Nice to meet you. How can I help you today?" It's a normal LLM reply. And then the user says, "What is 25 plus 17, right?" So in this case, what we expect the agent to go to the tools branch, and it's going to execute the addition tool. And that's actually what happened. So we have actually logged that here. We printed that out, that the agent have decided to use the addition tool, and the answer is 42. And the agent says 25 plus 17 is 42. And the user says, "Okay, do you remember my name?" So now this is the true test of the memory. An LLM without memory, if you ask it after a few turns, you ask it the same question, it's going to say, "No, I don't remember," because it doesn't have a memory. It doesn't have persistence of the memory. But in this case, it says, "Yes, I remember. Your name is Alice." So this is an indication that our memory saver is working as expected, which is very good. Now it's going to say, "Can you multiply that result by 2? This is actually a very important indication or test whether the agent remembers what we have told it at the beginning. So that result refers to 42. So hopefully the agent will use that and multiply it by 2. So now the agent decided to use the tool, multiplication tool, 42 times 2, which is great, which is what we expect. It took that result, 42, and multiplied by 2, and the result is 84. So the agent says 42 times 2 is 48, and that's great. So now the key takeaways are: memory saver stores the conversation history, thread ID keeps the conversation separate. So now, as you can see here, whenever we ask any question, when we invoke the agent, we invoke with the same thread ID, with the same conversation ID, which is conversation 1 in this case. So if we later, for example, pass a different conversation ID, it's not going to remember what happened in that conversation, right? So it's going to remember only the context of the conversation that you give it. For example, in this case, we give it conversation 1, so it's going to remember everything about that conversation. So agent remembers context across multiple turns. That's what we want to achieve in this video. And each invoke adds to the same conversation thread. So every message that we interact with the agent, it's going to be added to the message history. And this message history is going to be preserved throughout the turns. So now it's going to try with a different ID. So now it's going to give it conversation 2, for example, and see what happens. So now this is a new conversation with the ID conversation 2. So now a user says, "Do you remember my name?" The agent says, "I don't know your name. You haven't been introduced yet. You haven't shared your name with me in our conversation. Would you like to tell me your name?" So this is good. So now this tells us that, okay, conversation 2 didn't have any history before, and therefore the agent doesn't remember. So now with a different thread ID, the agent has no memory on the previous conversation. So that's actually was everything that I want to cover in this video. Thank you so much for sticking till the end. Stand by for the next episode. So thanks so much again for watching. See you in the next one. Bye bye.